Let's take a look at one more example where we are going to find some expected values. And so a process for producing an industrial chemical yields a product containing two types of impurities. For a specified sample from this process, let Y1 denote the proportion of impurities in the sample, and let Y2 denote the proportion of type 1 impurities found among all of the impurities. Right? So Y1 is the proportion of impurities in general, and then Y2 is among the impurities what proportion are type 1 impurities. So they have this joint distribution that is shown here. Right? So this is our joint distribution. We want to find what is the expected value of the proportion of type 1 impurities in the sample. Right? So really we should probably first figure out what are we trying to find the expected value of. And so we want the expected value of type 1 impurities. Right? So is that just Y1? Well, no, that's not quite just Y1. Actually, you might say, well, maybe it's actually Y2, because Y2, that is the proportion of type 1 impurities, but that's only among all impurities found. All right, so we need the proportion of impurities, type 1 impurities, and we're going to multiply that by the proportion of all of them that times the total number, or kind of the proportion of impurities in all of the samples. All right, so this is really what we want to look at. So we have an integral from negative infinity to infinity, negative infinity to infinity. We're going to have y1, y2 times the density, 1 minus y1, 2 times 1 minus y1, dy1, dy2. This is only going to be non-zero in these places, and so we have an integral from 0 to 1, right? So those are the limits for y2. Our limits for y1 are also going to be 0 and 1. And if we multiply this thing out, we have 2y1, y2 minus 2y1 squared, y2. And we are going to integrate this thing with respect to y1 first, and then with respect to y2. So we'll treat the y2's as constants when we go through and integrate this the first time. So when we integrate 2y1, y2, that's going to integrate to y1 squared, y2. When we integrate this next piece with respect to y1, we now have 2y1 cubed, y2. Remember, we're treating the y2 as a constant. So we've added 1 to the power of y1 divided by the new power. And we are going to evaluate this from values of y1 going from 0 to 1. Notice when we plug in 0, those will go away, the y1s will go away, and the terms will go away in their entirety. And so we are left with just y2 minus 2y2 over 3. And so now we want to integrate this thing from 0 to 1. And so we will add 1 to our powers of y2 and divide by the new powers. And we are evaluating this with values of y2 going from 0 to 1. Right? And when we do that, we get 1/2 minus 1/3, which would ultimately give us 1/6. Right? So the proportion of type 1 impurities in the sample, that proportion is 1/6. 1/6 of the sample has type 1 impurities. All right, thanks for listening. Next time, we'll look at our next chapter. Thanks.